Okay, in this question it says, sketch the shape of the graph showing the relationship between tangential or escape velocity and mass. And so what we've seen is velocity squared, we're going to call it escape velocity, is equal to 2gm1 over r. Now, if we were looking at the graphical relationship between two variables, we circle those variables. Those are the two variables that we're interested in. So in this case, if we were to look at it, we would say, okay, everything else goes away, and what I'm left with is v squared is equal to m1. We substitute in y squared equals x, which is a somewhat rather difficult graph for us to graph in a graphing calculator. So what we're going to do is we're going to go ahead and take the square root of both sides, and when we do that, we will get y is equal to the square root of x. But here's the key thing. Whenever you take the square root of x, it's actually plus or minus the square root of x. Okay, so what we get is we would get something along the lines of this. Now, the question is this is the graph we would get mathematically, but does it make sense to include the whole graph in terms of physical principles? And the question is can I have a positive mass that would give me some sort of negative velocity? And the answer is, of course I could. I could get a negative velocity value. That just means that the direction is different. This direction as opposed to this direction. Now, because it's actually ends up being a squared value, later on, this will actually go away because we're going to have a squared velocity value. But for now, actually, both values will work.